Next table that's in your note, oxyanion with the greatest number. Sometimes we'll have the prefix per. It will always end with 8. 1 less is 8. 1 less than that is 8. So I can see perchlorate. That's going to have ClO4. Chlorate is O3. Chlorite is O2. Hypochlorite is -1. So per means 1 more. Hypo means 1 less. I don't know that I'll ask a question about that, but all of those deal with the amount of oxygen that are in your compounds. For right now, I'm not concerned because these are on your cheat sheet, so you can look them up. You can look them up anyway. So now we're going to look at naming. We looked at how to write the formula, now we're going to look at naming. Here again, cation's always first, anion's always second. Monatomic cations, use the name, hydrogen, sodium, whatever. Anions are going to end with "ide." To distinguish the oxidation state, you have to write parentheses, so this is going to only be for your transition metals. So if I have a transition metal, my name is going to have parentheses in it. Otherwise, it's not. If it contains a polyatomic ion, you're going to name the cation and then use your anion that's on your cheat sheet. So you're just going to give it the names. Here's the way they show it. I'm going to, again, show you something a little bit different. But do notice here, iron 3 oxide, because iron is a transition metal. There's no parentheses here because my metal is not a transition metal. It's a normal group 1 or 2 metal. And then the last page is simply your review. I want to show you what I look at. So if I'm doing names. I am going to look at, all right, the cation is normally going to be a metal. If it's a group 1 or 2 metal, great. It's easy to name. Sodium chloride, potassium phosphate, whatever. If it's a transition metal, I am going to need parentheses in the name. And then I simply name the back part. So for example, I'm going to give you a formula. So I have K2O. You look at the front part. Look at the cation. Potassium is a what? Metal. Regular metal. I don't need parentheses. What's the name of this? Potassium. Second name? Oxide. Everything will have 2 names. It has a first name and a last name. The cation name and the anion name. So very simple part. Now I have MgOH2. Look at the front. Mg is a what? It's a what?
Metal.
It's a metal. It's a normal, it's a group 1 or 2 metal. So I name it magnesium. Second name is polyatomic, so I'm going to have to look at my cheat sheet, not my periodic table. What is OH?
Hydroxide.
Hydroxide. So all I'm going to write is hydroxide. Its name is magnesium hydroxide. First name cation, second name anion. Now, the tricky part. I have FeO. So Fe is iron. And iron is a what? It's a transition metal. So I'm going to put parentheses, and I'm going to leave them blank for right now. What's the second name? Oxide. I need to figure out the charge of my iron. What is the charge of oxygen? -2. How many oxygens do I have? 1. So my overall charge is -2. My iron is going to have a +2 charge to balance out. I have 1 iron, so what's the charge of that iron? 2. So this would be iron 2, and we use Roman numerals. Iron 2 oxide.
Question, so when you got the 2 for the iron, was it because of the valence electrons, or?
No, it's because of...
It's because of oxygen. You're always going to look at the back part. You're going to look at your anion.
Okay, so...
Let me do one more example. Let me do one more example that actually has some subscripts. So let's do manganese, and then let's do and I'm going to put a 2 there. Okay, so first name is what? Manganese. What do I know about manganese? It's a what?
It's a transition.
Transition metal. So I'm going to put parentheses there because I'm going to have to put something in it. What is the last name of that formula?
Sulfate.
Sulfate. It's in parentheses. It's polyatomic. Its last name is sulfate. What is the charge of sulfate?
-2.
-2. So I have 2 of these, which gives me an overall charge of -4. I only have 1 of these. What's the charge of manganese have to be?
4.
+4. So that those balance. So this would be manganese 4 sulfate. Does that make sense?
Yeah, I got it now.
Okay. All right, we'll do more practice problems then.